Let's study now some laws of logarithms. First law, log of x to the base a plus log of y to the base a. I can write this as single log, take the product of x and y to the same base a. So this is log x plus log y equal to what? Log of xy to the base a. So this is the very first rule or law of the logarithm. Now to prove this, we don't know anything about logarithm's rule. But logarithm is originated from the exponential. So if you could go or if you could reduce logarithmic form to exponential form, we can use laws of indices in order to get the results of logarithm. So what we do is, we will convert this logarithm in the exponential form. For that, what I have to do is, let me call this log x to the base a is equal to some p. Suppose this is some number p. And suppose this number log y to the base a is say q. Now how to convert logarithm into exponential form? Forget about this log. X is equal to a to the power p. Similarly, log y to the base a is equal to q. I want to go into what? Exponential. So forget about this log. What we have, y is equal to a to the power q. So from logarithm, I went to what? The exponential. From logarithm, I gone to what? Exponential. But here in this problem, I want the product of x and y. So let us take the product of these two. So if we take the product of these two, I get x into y is equal to a raised to p into a raised to q. Now from the laws of indices, we know that if the base is same, we can add the powers. So this means xy is equal to a raised to p and q being added, we got a raised to p plus q. Now using this, I want to go back to what? The result, which contains log, everything in terms of log. So let us convert now this into exponential form, in logarithmic form, sorry. So a raised to what? P plus q, I have xy. This I written like that. So right hand side is left hand side is right hand side. So a raised to p plus q is xy. This is the exponential form because a to some power is equal to some other result. So we know how to convert exponential into logarithm. Write the power is equal to log of opposite side, which is xy, to the same base a. So here p plus q, that is power, equal to log of opposite side, means log of xy to the base a. But recall that p is log x to the base a, q is log y to the base a. So let us write for p and q as log x to the base a plus log y to the base a is equal to log of xy to the base a. So this way the first result is being proved. So log x plus log y is log xy with the same base a. Please note that log x plus log y to the base a is not log of x plus y to the base a. Some students may think that log is common and hence x plus y is inside to the base a. This is the wrong conclusion. This is the wrong perception. So correct perception is what? Log x plus log y is single log and take the product of these two. For example, if I write log 2 to the base 5 plus log 3 to the base 5. Don't take log common because log itself doesn't exist if you don't have anything in front of it. So log of something makes sense. Just if I write log, it does not make any sense. I have to write log of something to the base something. Then it makes sense. So log 2 to the base 5 plus log 3 to the base 5. So because log itself does not exist, therefore I cannot take log as a common factor. It is not a factor. It is not a number. Log of 2 to the base 5 is a number. Just log is nothing. It is an operation, that operator we are operating on what? 2, and we are getting log to the base 5 is some number. So log 2 plus log 3 is log of 2 into 3. Multiply these two, what I get? 6 to the base what? 5. So this way, this is the result. One should not write like this. Now this idea of addition of logarithms can be extended to finite number of terms. That means, if I have, suppose log of x1 to the base a plus log of x2 to the base a plus dot 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 plus log xn to the base a. Then I can write with the help of this above result single log. Then I will take product of all these quantities, that is x1 multiplied by x2 multiplied by x3 dot 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 xn to the same base a. So log x plus log y is log xy. Likewise, log x1 plus log x2 plus log xn is log of x1 into x2 into dot 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 into xn to the base what? A. If base is same, we can do this. If base is not same, then we have to change the base and then we have to work. Here again one more fact is, when I add logarithms, their coefficients are each 1. Here coefficient is 1, here coefficient is 1. If it is the thing, then I can add logarithms, otherwise not. Let's go now for the result number 2. Result number 2 is for the subtraction of the logarithms. So let me take here the subtraction. So log x minus log y, what do you expect? You expect for sum it is a product. So for difference there should be what? The ratio. So log of x upon y should be the result that we are expecting. Let's see whether it is coming or not. So log x minus log y is log of x upon y. So negative term means this y will go in the denominator. Positive coefficient, here x will remain in the numerator. The way I proved the previous one, number 1, in the similar manner I can prove the second one. So in order to prove this, I had to go into what? Exponential. For that purpose, I had to call log x to the base a is some p, log y to the base a is some q, and then we can work out. So let's see how to work with this. So suppose log x to the base a is p, log y to the base a is some q. So convert into exponential, keep your hand on log. So x becomes a to the power what? P. Similarly, keep your hand on log, you get y is equal to a to the power q. Now you want here a division, x upon y. So let us take the ratio of the two. So we get x upon y is equal to a to the power p divided by a to the power q. So this is nothing but from the laws of indices, we get this as a to the power p minus q. So a to the power p minus q is x upon y. It is of the form a to the power x is equal to y. Then how we convert this into logarithmic form? Power equal to, so here power is what? P minus q is equal to log of opposite side. So log opposite side you write x upon y to the base a. So a should be written here. So from exponential it is converted into what? Logarithmic form. Now substitute for p and q, you will get the result. What is p? P is log x to the base a minus q is log y to the base a. Q is log y to the base a is equal to log of x divided by y to the base a. So log x minus log y is log of ratio of the numbers x and y. So it is like that. Again, remember that if I put over here negative sign, please do not take log common to write log of x minus y to the base a. This is the wrong perception. So log x minus log y is not equal to, it is not equal to log of x minus y. You cannot take log common because log as a, it is log x is a complete unit. You cannot just write log. Log does not make any sense. Log x to the base a may make sense. So log x minus log y is log x upon y. For example, log 5 to the base 2 minus log 10 to the base 2. Base is same. I can write this as log 5 divided by 10 to the base 2. Then you can calculate 5 by 10 as half. So this becomes log of half to the base 2. So this way one can talk about the difference of logarithms. So here coefficients are either 1 or what? Minus 1. Unless and until you have the coefficients of logarithm 1 or minus 1, you cannot add or subtract logarithms. Okay. So follow these rules. You can apply these rules in solving the problems also.